All right, so now we're going to polish up our algebra skills and our mental math skills by, remember I mentioned that we could figure out what 25 cubed is, but you can put all that in your calculator and do it, but you don't have to. Use your brain first. So we know that the 25 cubes are going to cancel out because I have negative 25 cubed and I have positive 25 cubed. What else is going to cancel out? I'm going to have negative 3 times 25 squared, but then over here I'm also going to have negative 3 times 25 squared, so those don't cancel. But positive 3 times 25 and positive 3 times 25, those ones do cancel. In fact, if you think about it structurally, since the terms of the two cubing formulas alternate, right? This one's positive, positive, positive. This one's positive, negative, positive, negative. All right. It makes sense that the alternate terms are going to cancel out. These terms are going to cancel. These terms are going to cancel. So these are the only ones you're really going to have. All right. So how else can we simplify this? So let's go ahead and keep our 1.17 over 2 times, and then we have negative this stuff up here. So let's think about how that's going to go. I'm going to have negative 3 times 25 squared delta t minus 3 times 25 squared delta t. So I can put that in my calculator and do 3 times 25 squared plus 3 times 25 squared or something like that. But think what you're going to do. So and it helps if you know some powers of numbers. Like if you know your powers of 3 are 3, 9, 27, 81, 243, 729. Right? Know your powers of 2, 2, 4, 8, 16, 32, 64. Know your powers of 5, 5, 25, 125, 625. You only need to know the first 4 to do this in your head. So, because we can do, all right, 625, that's 625. I'm going to multiply it by 3. So 3 times 600 is 1800, 3 times 25, 75. So that's 1875. But I'm going to have 2 of them. So I have 2 1875s. The 2 1800s are 3600, and then I got 150 more for my 275, so it's 3750. So I did that, saying it out takes longer than writing on a calculator, but the process actually could go through your head faster than you can do a calculator. And that's what mental math is about. So I have negative 3750 delta t. That's from, pen's flying all over. That's from these two terms. And then my last two terms are the negative delta t cubed plus negative delta t cubed. So I have minus 2 delta t cubed. Yeah. And then in the denominator, I just have delta t. All right, so that is, in fact, my simplified expression. I could make it a little bit nicer. Like I mentioned before that maybe it would have been nice at the beginning, instead of just factoring out 1.17, maybe factor out negative 1.17. That'll really sort of make it nicer here, where I can go negative 1.17 over 2 times 3750 delta t plus 2 delta t cubed. Remembering that delta t cubed means delta t is one variable and I'm cubing it, so it's not equal to delta cubed t cubed or anything like that. And my denominator is delta t. All right, so that now is my simplified expression. So let's see where that puts us here. Just find my page that I was on. All right, here we go. So, as awkward as that expression was, as awkward as all this stuff was that we went through, look what we come up with. This is actually a pretty simple expression, and it's going to get simpler. So, when we say record your simplified result, this is your answer to part F of recording the simplified result. Okay, so this expression achieved in part 6, which is all this stuff, gives the speed for any time interval delta t except delta t equals 0. Why is the expression not valid at delta t equals 0? So if you haven't thought about that yet, think about why this expression is not valid when delta t equals 0. Pause the video and come back. Write down the answer. All right, so hopefully you've had a chance to think about that, and you know that this expression is not valid when delta t is equal to 0 because the fraction will be undefined. You'll be dividing by 0, and we can't do that. All right, so now it says, it's tempting to reduce the factor delta t that occurs in numerator and denominator, and indeed it is valid to do so, but only when delta t is not equal to 0. All right, so what we're going to do is factor out the delta t and reduce the delta t factors, noting the change in domain. All right, so, you can just sort of go cancel, cancel, cancel like people do. But I want to really emphasize mathematically what you're doing and why it's a legitimate step. What you're really doing when you cancel the delta t's is you're factoring the delta t out of 3750 plus 2 delta t squared over delta t, and then you're reducing the delta t's and saying this equals negative 1.17 over 2 times 3750 plus 2 delta t squared. But crucially, only when delta t is not equal to 0. So this brings us to one of the very typical things that happens in calculus is we have a nice useful expression. I'll show in a minute how terribly useful it is. However, this expression is valid and equivalent to this expression for any real number, for any of the infinitely many real numbers in the universe, except one of them. Delta t equals 0 is the only point for which our expression was not valid. And of course, if I'm interested in this instantaneous time, delta t equals 0 is exactly what I want. So it's what I need to evaluate. So that, in fact, is sort of the fundamental conundrum that keeps coming up with calculus. Is you get nice expressions that describe something perfectly everywhere you want, except at the one place where you want it. So we'll examine what that means in our next video.